Good morning, dear students. Very happy Yugadi to all of you. Am I audible? Yes. Okay, fine. Yes. So, good morning, dear students. Okay. So, and a very happy Yugadi to all of you. Okay. So, may this year bring you lot of success in your life. Okay. So, yes. So, going through the today's class. Yes. So today we are going to start with the next chapter of PUC first year, that is redox reaction. Okay. So what do you mean by redox reaction? So redox reactions are those reactions in which simultaneously oxidation and reduction takes place, right? So did you go through the synopsis? Yes. I hope you have gone through the synopsis which was sent. Yes. So based on the synopsis, okay, we are going to discuss some important questions, okay, important MCQs. So let us start. Okay, so this is a first question. Which of the following is not an example of redox reaction? So you have to see such a reaction. Now we know what is redox reaction, right? So redox reactions are those reactions in which simultaneously oxidation and reduction takes place. Okay. So in the same reaction, there should be oxidation and reduction going on. Now, can you tell me in the same? So these are the four options. So which is not an example of redox reaction? Means in which of the examples there is no oxidation and reduction taking place simultaneously? Yes. Okay, Madan has answered it as D. What about others? Okay, so you have to check for the oxidation states. Okay, you have to check for the oxidation state in each case. So there should be, so what is oxidation? We know oxidation is either increase in oxidation number, okay, loss of electrons, that addition of oxygen, removal of hydrogen. So these are the definition of what? Oxidation. And what is reduction? Reduction is addition of hydrogen, okay, removal of oxygen, then decrease in oxidation number, right, and gain of electron. So these are the definition of reduction. So when we see, when we apply here, so if we see BaCl2, okay, Ba is +2, Cl is, each Cl is -1, plus H2SO4, okay, it gives you what? It gives you BaSO4, right? So here uh, each, so if you check the oxidation state of BaSO4, okay, so here if I don't know what is the oxidation state of barium, so let me keep it like that, okay, then sulfate ion, so this is -2, this is +2, okay, so this is also +2. You can see that barium is +2, sulfate is -2, okay, so +2 and -2, +2 HCl, Cl is -1 and here it is +1. So what you can see here, yes, what you can see here, you can see that there is no change in your this what oxidation number. It is same, right? It is same. So it is not an example of redox reaction. So let me take any one of this. Let me take the K plus F2 giving you 2KF. Okay. Now if you see this, K is what? +1, right? Chlorine is 0. So whenever you have any diatomic molecule, then it will have 0 oxidation state. Then here again, K is +1 and here it is -1. Okay. So here it will be, sorry, K will be your, okay, it is in free state. Okay, it is in free state, so it will be 0. So what you can see that here, okay, there is increase in oxidation and here it is decrease in oxidation. Okay, so here it is undergoing oxidation and here it is undergoing reduction. Right. So simultaneously, okay, in the same reaction, oxidation and reduction takes place. So this was the example of what? This was the example of a redox reaction. So which is not the example of redox reaction is option number D. Okay, option number D. Fine. Is it clear? So let us go for the next one. So of the following reaction, only one is redox reaction. Identify it. Yes, of the following reaction, only one is a redox reaction. So please identify it, which is a redox reaction. Redox reaction means there should be increase in oxidation number and decrease in oxidation number simultaneously. Okay, Madan has answered it as D. What about others? Yes. Okay, Pavitra has answered it as D. So we know that, okay, in reduction, in oxidation, simultaneously oxidation and reduction takes place. So if we consider this particular reaction, FeO giving you 2Cu plus 2Fe plus SO2. Okay, so here the oxidation number of copper here is how much? It is plus 1. Okay, it is plus 1. So plus 1 into 2, it will be plus this and this will be minus 2. Okay. So copper is plus 2. This is plus 2. This is minus 2. Now here, the oxidation, what is happening? From plus 1, it is undergoing reduction to 0. So it is undergoing reduction. Okay, gain of electron. Right. But for sulfur, it is minus 2. And here it is how much? It is minus 4. So this is plus 4. Okay, so from minus 2, it is undergoing plus 4. So what is happening? Oxidation is taking place. Right. So this is the reaction where oxidation and reduction takes place simultaneously. Now, if I consider some other reaction, let me take BaCl2 plus MgSO4 giving you barium sulfate plus, this is a displacement reaction. Okay, it is a displacement reaction, double displacement reaction. It is not an example of redox reaction. Now here Ba is plus 2, Cl, each Cl is minus 1, Mg is plus 2, each sulfate is minus 2, plus 2, minus 2, plus 2, minus 1. So can you see any change here? Yes, can you change? Can you see any change? Yes, no, you cannot see any change, right? So this is not the example. So the other examples are not the examples of oxidation. So option number D is the correct one. Yes, Vamshi Krishna has also answered. Very good. Okay. So let us go for the next one. The oxide which cannot act as a reducing agent is. So which is the oxide which do not act as a reducing agent? Oxide which cannot act as a reducing agent. What do you mean by reducing agent? So reducing agent, it reduces other and itself undergoes oxidation. Okay, reducing agent, it itself it reduces other and itself undergoes oxidation. Okay. Okay, Syed has answered it as C. So which is a good reducing agent, which cannot be acting as a reducing agent. So you have NO2, SO2, CO2 and ClO2. Okay. Vamshi Krishna has also answered it as C. Okay, let us see here. So here, yes, option number C is the correct answer. So when we see this, so carbon, okay, carbon dioxide. So carbon dioxide is what? So oxygen is here minus 2, right? 2 oxygen. So it is what? Minus 2 into 2 will be minus 4 and this is plus 4. Okay. So here the oxidation state, maximum oxidation state, what carbon can have is plus 4. Right, we know that. So the maximum oxidation state shown by carbon is what? Plus 4. Okay. And therefore, the carbon dioxide, it cannot act as a reducing agent because it can, reducing agent means what? It should reduce other. Okay, it should give electrons to other and itself undergoes oxidation. But here already it has lost 4 electrons. So how it can be a good reducing agent? So carbon dioxide. Okay, carbon dioxide is a good reducing agent. So reducing agent should have that ability to give electrons. Okay. But your carbon has already lost its 4 electrons. So it cannot act as a reducing agent. But rest other this okay molecules, they can act as a reducing agent. Okay. Next one, Zn plus 2 plus 2 electrons. Okay, now here you can see Zn plus 2 aqueous, okay, plus 2 electrons. So it has, what it has done, it has accept a pair of electrons. It has accept, okay, it has accepted electron. So when we accept electron, when we gain electron, what it is termed as, this is a definition of what, okay, in terms of electrons. So we are discussing about the definition in terms of electrons. So when we accept electrons or when we gain electrons. Okay. So what it is termed as reduction. Yes, very good. So it is a reduction. Okay. So Zn plus 2, when it is giving to when it is taking to electron, okay. So it is called as so it is undergoing reduction. Okay, it is undergoing reduction from Zn plus 2 to Zn. Okay, it is a gain of electron takes place. So because of that, it is undergoing reduction. Okay. Madan has also answered. Vamshi Krishna has also answered. Very good. Okay. So let us go for the next one. The oxidation number of an element in a compound is evaluated on the basis of certain rules. Which of the following rules is not correct in this? Okay, so there are incomplete options. Okay, let us skip the question. Let us go for the next one. In which of the following compounds the oxidation number of iodine is fractional? So, in which of the following compound this is fractional? So, eighth one, okay, IF7, I minus 3, then this is IF5. Okay, consider this is IF5, IF5, and this is IF3. Okay, so Syed has answered it as B. Madan has also answered it as B. Yes, what is the oxidation state of iodine? So if I check for all, so IF7, so each fluorine is -1. So this will be -7. Okay, and this is +7. So the iodine oxidation state is +7. Okay, then I minus 3. Sorry, I minus 3. I3 minus. Okay, so I3 minus is what? I3 minus is, so if I take X is equals to, so the oxidation number of iodine in this is 1 minus 3. Hmm. Okay, 1 minus 3. So this is also correct. Then IF5. Okay, so this is +5. So the oxidation number is +5. Then IF3 is, it is +3. Okay, so option number B. Yes, B is the correct answer. So Madan Vamshi Krishna has answered. Syed has also answered. Very good. Okay, let us go for the next one. Oxidation numbers of phosphorus in phosphate and sulfur in sulfate and chromium in chromate are respectively. So find the oxidation states. So P4 minus 3, XO4 minus 2. So when we are finding the oxidation state, oxidation numbers, so that time you need to know a set of rules. Okay. So please go through the set of rules, some common oxidation numbers, so that you need to know. Okay, if you know that, then it is very easy. Okay, so put X plus, how many oxygens are there? 4 oxygens are there. Each oxygen is -2. The whole charge is 3. Substitute this. Sulfur X plus, how many oxygens are there? 4 oxygens are there. Each charge is -2 is equals to -2. Okay, then one more was Cr2O7 minus 2. Chromium is 2x plus 7 into -2 equals to -2. Okay, so solve this. Solve this following. So this is x minus 8 is equals to -3. X is equals to -3 plus 8. So this will be 5. Okay, x is equals to 5. So this is 5. Then x minus 8 is equals to -2. X is equals to 2. plus 8 is equals to 6. X is equals to 6. Okay. Then next here 2x minus 14, 2x minus 14 is equals to minus 2. 2x is equals to minus 2 plus 14. So it is 2x is equals to 12. X is equals to 6. Yes. So it is plus 5 plus 6 and plus 6. So plus 5 plus 6 and plus 6 is option number D. Yes, Vamshi Krishna, Chinmaya, Pavitra and Madan have answered it right. Very good. So whenever if they ask you to find the oxidation numbers, okay, oxidation state or oxidation numbers of certain elements, you need to know set of rules. Okay, so few oxidation numbers you need to know. That is the common oxidation numbers, oxidation state of such elements. So please go through the textbook again. Okay, rules are given even in the synopsis. Okay, the rules are mentioned again. So please go through that. So if you know that only, then you can solve such questions. Okay, so these are very easy if you know the rules. Okay, so let us go for the next one. The oxidation number of nitrogen in NO3 minus is. So NO3 minus, so what is the oxidation state? Put it as X plus 3 into minus 2. So common oxidation state of oxygen is minus 2 is equals to minus 1. Okay, the charge here is minus, so it is minus 1. So X minus 3 to the 6 is equals to minus 1. So X is equals to minus 1 plus 6 is equals to 5. Okay, let us see the reaction. Okay, so let us see. So 4P plus 3KOH plus 3H2O giving you 3KH2PO2 plus PH3. So what is happening in this reaction? Yes, what is happening in this reaction? So here, if you see the oxidation state, okay, so oxidation state of phosphorus is 0. Okay, then in KH2PO2. Okay, so what is the oxidation state? It is plus 1. Okay, it is plus 1. And in pH3, the phosphorus oxidation state is minus 3. Okay, so what is happening to oxygen? This your phosphorus. Phosphorus is getting it is getting uh, what it is getting reduced as well as it is getting oxidized. Okay, so it is undergoing both. So it is getting oxidized also and it is getting reduced also. So it is undergoing oxidation and it is going reduction. So phosphorus is both oxidized as well as reduced. So option number C. Yes, Madan has answered it. So option number C is the correct answer. Okay. Now again, the oxidation number of Mn in KMnO4 is. So what is the oxidation state of Mn in KMnO4? So potassium common oxidation state is plus 1. So if we put Mn as X is equal plus 4 oxygens Each oxygen is -2. There is no charge on the molecule. So it is 0. So X, then it is -8. Okay, so sorry here. So it will be X plus X minus 8 is equals to 0. So X, okay, minus 7 equals to 0. So X is equals to 7. Okay, so A, yes, Madan has answered, Pavitra has answered. Very good. So it is plus 7. Okay, it is plus 7. So the oxidation number of Mn in KMnO4 is plus 7. Okay, let us go for the next one. Iodine shows the highest oxidation state in which compound? So let us find the oxidation state of iodine. Okay, so here in Ki, when we consider the Ki compound, that is potassium iodide, and then we see the oxidation state of iodine. Okay, so here you see, you know that the potassium is +1. Okay, and this is -1. So the oxidation state is -1. Okay. Then, so this is +1, this is -1. So the oxidation state is -1. Then, next is Ki3. Ki3, Ki3. Okay, so potassium is what? Your potassium is +1. Okay, and your iodine is what? So if I put it like this, +1 plus 3x is equals to 0. Then x is equals to minus 1/3. Okay. So this is oxidation state. Then next is IF5. So fluorine is -5. Each fluorine is -1 into 5. And this is +5. Then KiO4. Yes, KiO4. So what will happen here? Potassium is +1. Iodine will keep it as X plus 4 into -2 equals to 0. So 1 plus X minus 8 is equals to 0. So X is equals to 7 plus 7. So the highest is in D, option number D. Yes, Madan and Vamshi Krishna has answered it right. So option number D. So like this, the question is asked. Okay. Let us go for the next one. So others also please answer the oxidation number of carbon in oxalates. So this is the oxalic acid. Yes. Others, please answer. Madan has answered it as +3. What about others? So there are two hydrogens. Okay. Then we have to find the oxidation state of carbons. 2x plus 4 into -2 equals to 0. So 2 plus 2x minus 8 equals to 0. 2x minus 6 is equals to 0. Then 2x is equals to 6. X is equals to 3. Yes, plus 3. Yes, Pavitra has also got it as B. What about others? Yes. Okay, let us go for the next one. I hope you are getting, yes. Next one, oxidation number of phosphorus in KH2PO2 is. Yes, find out the oxidation number of phosphorus in particular. So KH2PO2. So K is +1 plus 2 hydrogens. Okay, +1 plus X plus 2 into -2 equals to 0. Solve this. So 1 plus 2 ones are 2. Okay, plus X minus 4 equals to 0. 3. Yes, Chinmaya has got as A. Others, did you get the same? Okay, let us go for the next one. Option number A. Okay, so +1. Just now we have seen that. So it is +1 oxidation state. So option number A is the correct answer. Okay. So whoever did not get, you can copy down. Okay. So let us go to the next one. Which one of the following involves transfer of 5 electrons? So which involves the transfer of 5 electrons? So if you see the oxidation state of MnO4 minus, okay, so here X plus 4 minus 2 equals to 0. So, sorry, minus 1. The charge is minus 1. X minus 8 is equals to minus 1. X is equals to minus 1 plus 8. S is equals to 7. Okay, and here it is plus 2. So from plus 7 to plus 2. So there is 5 electrons transferred. Okay, so same way, if you check for others, okay, so let us check. So Cr2O4 minus, here it is X plus 4 into minus 2 equals to minus 2. So X minus 8 is equals to minus 2. X is equals to minus 2 plus 8. So it is 6. 6. And here it is how much? From plus 6 to plus 3. So 3 electrons. Okay. Then MnO4 2 minus. So X plus 4 into minus 2 equals to minus 2. X minus 8 is equals to minus 2. X is equals to minus 2 plus 8, 6. So X is equals to 6. So from 6 to your MnO2, this is minus 4 plus 2. So this is plus 4. So 2 electrons again. Then last Cr2O7 2 minus. So 2x plus 7 into minus 2 equals to minus 2. 2x minus 14 is equals to 2. So 2x is equals to 12. So it is again 6 electrons. So this is plus 6 and this is 3. So again 3 electrons. So you can see option number A. So in option number A, you can see there are transfer of 5 electrons, right? So Madan and Chinmaya has answered. Very good. Okay, so you can find out like this. So like this, you have to find out, okay, first you have to find out the oxidation states of each, and then you can see how much electrons are lost. So from plus 7 to plus 2 means 5 electrons are lost. So plus 6 to plus 3. Okay, so 3 electrons are lost. So like this, you can calculate. Is it clear? Yes. Shall we move to the next? Next one. Nitric oxide acts as a reducing agent in the reaction. What is the role of reducing agent? It reduces other and itself undergoes oxidation. So which is the answer? Madan has answered it as B. Reducing agent, it should reduce other and itself undergoes oxidation. So it should add electrons to other. So if your nitrogen is in +2 oxidation state, okay, and here it is NO3 minus, so X plus 3 into minus 2 equals to minus 1. So X 3 to just 6 is equals to minus 1. So X is equals to minus 1 plus 6. So it is 5. So it is plus 5 electrons. Okay, plus 5. So it is undergoing what? There is increase in oxidation number. Right, increase in oxidation number. Right. So what is happening here? So it changes from +2 to +5. So it is acting as a reducing agent. So it reduces other and itself undergoes oxidation. Okay, so there is a loss of electrons. So it will reduce other. So here it is 0 and this is minus 1. So it reduces other and it is undergoing, it is reducing other and itself undergoes oxidation. So it is undergoing oxidation and it is reducing iodine. So option number B. Yes, in option number B, yes, Vamshi Krishna has also answered. So in option number B, you can see that the nitric oxide, it is acting as a reducing agent. So it is reducing other and itself undergoing oxidation. Okay. In the following reaction, so what all is happening? Let us see. So Br2, 3Br2 plus 6 carbonate plus 3H2O, giving you 5Br minus plus BrO3 minus plus 6HCO3 minus. Okay. So this is 0. Then, so your carbon CO3 minus 2. So 3 into minus 2 equals to minus 2. X minus 3 to just 6 is equals to minus 2. X is equals to minus 2 plus 6. So it is plus 4. Okay. So here the oxidation state is plus 4. So this is plus 4. This is 0. Then H2 again. Br is minus 1. Your Br is how much? BrO3 minus. So x plus 3 into minus 2 equals to minus 1. X minus 3 to the 6 is equals to minus 1. X is equals to minus 1 plus 6. So it is 5. So it is undergoing plus 5 oxidation state. Okay. So your bromine is undergoing reduction also, and it is undergoing oxidation also. Right. So option number D. Option number D. So bromine is both reduced as well as oxidized. So Madan, Chinmaya, and Vamshi Krishna has answered. Very good. Okay. So you can see that bromine, it is zero oxidation. So it is undergoing -1 and +3 oxidation state. So both. Okay. It is undergoing reduction also and it is undergoing oxidation also. Okay. Let us go for the next one. The oxidation number of sulfur in Na2S4O6 is. So what is the oxidation number of sulfur in Na2S4O6 is? So Na2S4O6. So here we are finding the oxidation state of sulfur. So each sodium is +1. So +1 into, sorry, we'll write it like this. So 2 into +1, each, this is +1, plus 4x plus 6 into -2 equals to 0. So 2 ones are 2 plus 4x minus 12 equals to 0. So 4x minus 10 equals to 0. Right. Okay. So it is 2.5. B. Yes, Chinmaya has got it. What about others? Yes, it is 2.5. So oxidation number of sulfur in Na2S4O6 is 2.5. Got it? Yes? Okay. Let us go for the next one. The oxygen has an oxidation state of +2 in which compound? Okay. So we know that. Okay. We know that. So H2O2. Okay. Each hydrogen is +1. So there are two hydrogens. So it is +2 and each oxygen is -1. So oxidation state of oxygen here is -1. Then carbon dioxide. Okay. Each oxygen is -2. Okay, so there are two, so it is -4, and this is +4. So here each oxygen is -2. Okay, -2. Now H2O. Here H2O is how much? H2O is also -2 because H2O, this is +1 into 2. Okay, and this is -2. Then in this case, fluorine is a -1. So -1 into 2 is -2. And this is +2. So here in oxofluorides. So remember that exceptional cases where oxygen will have +2 is in oxofluoride. So when it forms oxofluoride compound. So option number D. Yes. Okay. Option number D is the correct answer. So when oxygen forms oxofluoride compounds, it will be in +2 oxidation state. Okay. Fine. Let us go for the next one. The standard reduction potential of four elements A, B, and C are and D are minus 3.05, minus 1.66, minus 0.44, and plus 0.80. The highest chemical reactivity will be exhibited by. The highest chemical reactivity will be exhibited by. Yes, Madan and Chinmay has answered as A, and A is the correct answer. Okay, so when we see the standard electrode potential, okay, standard electrode potentials are nothing but the reduction potential. Okay, and the reduction potential of A, it is minus 3.05. So it is the least, right? So it is minus, so its oxidation potential will be maximum. Right, its reduction potential is minimum, but its oxidation potential is maximum. So because of that, your A will be more reactive. It is highly reactive. Okay, let us go for the next one. The violent reaction between sodium and water is an example of. Yes, the violent reaction between sodium and water is an example of reduction, oxidation, redox reaction, and neutralization reaction. Chinmaya, Madan, and Vamsi Krishna is answered as C. So if we react sodium in water, okay. So let us see what happens. So 2NaOH plus H2 gas will be liberated. So H2 is 0, sodium is 0, here plus 1, okay, and here it is plus 1, minus 2, and plus 1, right? So what is happening here? Just see. So sodium, okay, so it is undergoing uh, oxidation, okay, and your hydrogen is undergoing reduction. Okay, so what you can see, so sodium is oxidized, okay, to NaOH, and H2O is reduced to H2. So it is an example of redox reaction. Yes, option number C is the correct answer. Okay, let us go for the next one. Br minus is converted to Br2 by using. So how Br minus is converted to Br2? So this is minus 1, this is 0. So how it is converted? So what it is undergoing? It is undergoing oxidation, right? It is undergoing oxidation. So there will be loss of electron. So, so if you if you want to convert it into Br2, okay. So if you take the any halogen which is placed above in the periodic table, so what it will do? It will reduce the it will oxidize the halide ion, okay, of halogen. So what it if you use Cl2, if you use Cl2, so it will become Br2 and 2Cl minus. Okay. So option number A. Option number A is the correct one. Yes, Chinmaya and Madan has answered. Very good. Next, oxidation state of oxygen in hydrogen peroxide is. So what is the oxidation state of oxygen in hydrogen peroxide? Each hydrogen is plus 1. So 2 hydrogens plus, okay, 2x. I can write it as 2x is equals to 0. So 2 plus 2 plus 2x is equals to 0. So 2x is equals to minus 2. So x is equals to minus 2 by 2. So it is minus 1. Okay. So it is what? Minus 1. Is it? Yes. 59th. Okay. So it is minus 1. Are you getting the same? Yes. Chinmaya and Madan have got it as minus 1. What about others? Yes. Others are solving or no? Okay. So the oxidation state. So like this you have to find out. So it is minus 1. Got it? Yes. Shall we move for the next one? In ferrous ammonium sulfate, what is the oxidation number of Fe? What is ferrous ammonium sulfate? It is FeSO4 dot NH4 twice SO4. Okay, giving you FeSO4 plus NH4 twice sulfate. Okay, so here what is happening to ferrous sulfate? So FeSO4 is undergoing Fe plus 2 plus SO4 minus 2. So Fe here is in what it is undergoing, what is the oxidation state here is plus 2. Yes, B. B is the correct answer. So Chinmaya has answered it right. Yes. Yes, Madan has also answered it right. Very good. So it is plus 2. Okay. Fine. Let us go for the next one. When KMNO4 is reduced with oxalic acid in acidic medium, the oxidation number of Mn changes from. So MnO2, okay, if it is reduced, okay, when it is reduced with oxalic acid in acidic medium, so MnO2, it changes from MnO4 minus to Mn plus 2. So the oxidation state of Mn here is plus, and this is plus 2. Okay, so the oxidation number, it changes from plus 7 to plus 2. So plus 7 to plus 2. So option number C. Yes, Chinmaya, Madan and Vamshi Krishna has answered it right. Very good. Okay. Let us go for the next one. The values of X and Y in the following redox reaction is. What is the values of X and Y in the following redox reaction? Here is minus 1. Here it is ClO3 minus X plus 3 into minus 2 equals to minus 1. So X minus 3 to just 6 is equals to minus 1. X is equals to minus 1 plus 6. So it is 5 plus 5. Okay. Chlorine here is 0. So here the change in oxidation state is by minus 1. And here it is by plus 4. Okay. So if you put here, what is X and Y? So here you can see the change in oxidation state is by plus 4 and here it is by minus. So plus 4 plus 5 and minus 1. Okay. So it will be 4. So here what they have done is here they have multiplied. So if we balance it, okay, if we are so if we see the change in oxidation number and when we balance it, we get this equation. So 3Cl2 and 5Cl. So it is option number C. Yes, Chinmaya, Vamshi Krishna and Madan have got it. So option number C is the answer. Okay, let us go for the next one. Which reaction is not feasible? Not feasible means which will not work. Which reaction is not feasible? So if you see this reaction, option number B, okay, here Br minus is there. This is I2, this is 0. Here it is plus 1, minus 1, this is plus 1. So what you can see here, the reaction is not possible here because Br minus is not oxidized. Okay, it is not oxidized in Br2 with I2. Okay, and due to higher electrode potential, because the electrode potential of the I2 is higher. Okay, uh, it is higher than that of I2. So Br2 is having higher oxidation potential than that of Br2. So because of that, option number B is the correct answer. Okay. So this reaction is not feasible. It will not work. So what is the oxidation state of osmium in OSO4? So x plus 4 into minus 2 equals to 0. X minus 8 is equals to 0. X is equals to plus 8. Option number D. Yes. Madan and Chinmaya has answered. Very good. So plus 8 is the answer. Okay. What is the oxidation number of N in N3H? That is hydrazoic acid. So what is the oxidation state of N in N3H? So X plus. Okay, so it is A. Yes, Chinmay and Madan has got it. So it is A. Okay, minus 1 by 3. What about others? Yes, everybody is solving, right? Okay. So let us go for the next one. One of the following has both positive and negative oxidation state. So which among the following will have same positive as well as negative oxidation state? Yes, Chinmay has answered. Very good. So it is B. So chlorine, okay, chlorine has the oxidation state of minus 1, plus 1, plus 3, plus 5, and plus 7. Okay, so chlorine has this oxidation state. So yes, Madan has also answered. Very good. So the chlorine will have both positive as well as negative oxidation states. Very good. Let us go for the next one. HNO3, it acts as what? It acts as an acid, it acts as an oxidizing agent, it acts as reducing agent, or it will act both A and B. So if you see the oxidation state of nitric acid, so it is plus 1. So plus 1 plus x plus 3 into minus 2 equals to 0. 1 plus x minus 3, 6. So x minus 5 equals to 0. X is equals to 5. So it is plus 5. Okay. So here you can see in HNO3, the oxidation number of nitrogen is plus 5. Okay. So this is the maximum value. Okay. A nitrogen can have. Hence, it is acting as a oxidizing agent and as an acid also. So it is option number D. It is what? Option number D. It acts as both oxidizing agent as well as reducing agent. So oxidizing agent as well as acid. Yes, option number D. So Madan, Chinmaya, and Vamshi Krishna has answered. Madan and Chinmaya has answered it correct. Okay. Vamshi Krishna, both. It is acting as acid also. HNO3 is acid. Okay. It is acid, so we take it as acid also, and we use this as oxidizing agent. Oxidizing what agent? What is the role of oxidizing agent? It oxidizes other and itself undergoes reduction, right? So it is having the maximum value. So further, it cannot lose electrons, right? So it is acting as a. The atomic number of an element is 22. The highest oxidation state exhibited by it in its compound is. Chinmaya has answered as D. So it is titanium. Okay, titanium has atomic number of 22. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d. So it is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, then 19, 20, 21, 22. Okay. So now here the D and F. Okay, so sorry, D and S is very close. Okay, the energy level is very close. So it can have maximum of electrons it can lose is +4. So the highest oxidation state exhibited by it in its compound is +4. Yes, Madan, Pavitra, and Vamshi Krishna has answered it correct. Very good. So option number D is the correct answer. Okay, let us go for the next one. The oxidation state of chromium in the final product formed by the reaction between Ki and acidified potassium chromate is. So K2Cr2O7 minus 2. Okay, when you react it with the iodine in the presence of H plus ion, okay, it is an acidified solution. You get 2Cr plus 3I2 plus 7H2O. So when you see the oxidation states here, so here the oxidation state of chromium in the final product formed by the reaction between this is. So it is what? It is +3. Yes, Madan, Chinmaya, and Vamshi Krishna has answered it as +3. Okay. Is it clear? Okay. Okay. So by this, we complete the chapter redox reactions. Okay. Is it clear? Any doubts? Do you have any doubts on this topic? Yes. So very important. So whatever the synopsis have been sent, so from that I have taken these important questions. Okay. So you can, as I always say, so please again read the synopsis and solve some more questions. Okay. It will help you. It will help you, and it will also like whatever you have studied, it will be helpful for you. Okay. It will what again, it will be a practice for you. Okay. So that you will be more confident enough to solve much problems. Okay, fine. So today, okay, after completing all the classes, so you'll be the link will be sent. Okay, test will be there on this particular chapter. Please attend the test. So tests are very important. Okay, so you will get your result there and there itself. So please attend the tests also. Fine. So thank you. Okay, I hope you have understood everything, right? Others who were not answering also, I hope you have understood. Yes, so please go. I know you have understood everything. Only thing you shy. Okay. So what you can do, please go through the synopsis once again and solve some questions. Okay. So that it will help you more. Okay. So by this, I'll end the session here. Okay. Thank you. Thank you, dear students. Have a good day.